Hey everybody, this is Jim Need from Jim Need Woodworks. Recently I had some problems with the proximity sensors and homing being consistent, and then I started noticing on some of my axes on one end or the other where I had some inconsistency where Mach 4s seemed to be behaving differently. And I never really dug into how the hard stops and proximity sensors and the soft limits all work together on the machine, and so I spent some time to try and figure it all out and adjust my machine. And then I noticed that there was quite a few other people on some of the forums that didn't really understand it like I didn't either. So I thought I'd do a quick video and just kind of explain what the purpose of each of them are and how to set them up correctly, and how you can use the soft limits maybe to your advantage for some other things. So this is going to be for AVID machines that have the proximity sensor kit and the ESS, which comes in the standard electronic packages. If you've built your own machine and don't use the ESS controller or didn't get the proximity sensors, some of what I'm talking about isn't going to apply, because there's a whole bunch of other ways to do homing and set your machine up. But I think the majority of the AVID users are using kind of the full package with just the standard electronics and the proximity sensors. And they're also, if you've built your own machine, you probably know what you're doing completely anyway, or you've had to figure it out to get it working. So this is really for those with the standard machine. When it's working correctly, I want to show that the value of the soft limits are that the software, the ESS, when it commands the gantry to go to one way or the other, or the Z stage to go up and down, it knows exactly where it's supposed to stop, and it won't let you slam it into the end of a stage. And if you don't have the soft limit set up, you can slam it into the end so hard you can easily bend your hard stop. So I've got my machine set up for my rapid jogging is 1,000 inches per minute, which is fast, and I'll show you the machine decelerates nicely and stops at the end without destroying anything. So in that case, I held my jog on completely the whole time. I didn't stop it, but the machine knew better and started to decelerate from the full speed and stop at the right time. The other nice thing about having it all set up correctly is when you're running G code, and the processor in Mach 4 runs across a command that would cause it to go outside of the soft limits, it's just simply going to stop and say, hey, that's outside the soft limits. And so it won't, and it usually has a look ahead, so it's usually going to do that before it gets to the command. But no matter what, it's not going to go try and run that cut or that laser burn or whatever. It's not going to go up to the edge and then slam into your end of your table and then sit there and stop. It's actually going to stop nicely and let you know that, and that's also very nice because it doesn't mess things up as bad as it could. It gives you a chance to at least stop the machine well. And the third thing that's nice about that is if you don't have the soft limits and it slams into the hard stop or it hits a proximity sensor, the proximity sensors are just like your EMO button. So if you run against the proximity sensor, Mach 4 is going to stop it fast, and your motors are probably going to lose steps, and that means your whole homing and everything is all out of whack, and you've got to rehome and start it over. So you don't really have a good chance. You're basically going to have to start the whole G-code file or whatever from the beginning and rehome your machine. Whereas if you violate a soft limit, the machine is going to stop gracefully and your homing is still all valid and everything. You still may have to stop and move your material, because if you're violating soft limits, it probably means your design is too big for your table, or the position that you place your material on the table needs to be shifted one way or the other to keep the whole thing within the limits. But at least it has some it gives you some opportunity to restart gracefully instead of like ruining the workpiece right away, or forcing you to have to re-home the whole machine. So let's get into all the pieces first, all the hardware pieces, and then I'm going to go over the software settings that go along with it in the ESS plugin and Mach 4. Okay, when your machine powers on, it's a little bit disoriented and has really no idea where it is. So I just turned on this machine, and you can see the gantry X and Y are both about in the center of the table, and the Z stage is way up at the top. So if we look at what Mach 4 says, I'll enable it. Mach 4, these are the work coordinates, and basically it remembered where it was last time I had it on. So these are kind of bogus values, they're just in there. But if I go over to machine coordinates, boom, everything is exactly 0. So what it does when Mach 4 comes up is it just goes, yeah, where I am must be 0, 0, 0, and it really has no idea. Clearly that's not 0, 0, 0, because on my machine the very front homes to 0, the very left of the X stage homes to 0, and 0 is actually up at the top where that is, or sorry, at the bottom, and the top there where the sensor trips is supposed to be minus 14. So this thing is way off, and that's what homing is going to do. It's going to set this up to be in the right place. Like if I move towards the front where 0 would be, up close to there, you can see it says Y is minus 15.7. Well, it should never let me go to a place like that. I can only go down to 0, and my soft limits should kick in and stop me from going past 0. So clearly it's messed up. So we're going to go through how the homing works, but that's exactly what we're trying to do when we get this machine homed, is to orient itself on all axes with respect to the physical reality of the system, and then everything going forward can be referenced to those points, and the machine can behave nicely without damaging itself. All right, let's go over the various hardware components first. First, we'll start with the hard stop. So the gantry movement forward and back, which is the y-axis, has 4 hard stops. There's 2 in the front, and then there's 2 in the back here. 1 here, 1 over there. So those are not adjustable. They just basically have this rubber bumper down here, and the front part of the motor and gear assembly just bumps against that. Then on the gantry, the x-axis has 1 on the right side and 1 on the left side in the front. Same kind of bumper deal, and the Z stage itself can run into that. And then up inside the Z stage, it's basically got hard stops inside. It can only go up and down so far before it mechanically stops. So, and then if you have a rotary axis like this, there is no hard stop on that, because the way it operates needs to be able to spin multiple times. So it can go around and around forever. So those are the hard stops. They are not meant to be really used. You should never, if everything's set up properly, your system should not go banging up against those. They're really there just kind of as a safety aspect in case if everything else fails, or when the machine is powered off and you're manually sliding one of these, either the X or Y stage around, you can't, if this wasn't here, this would just slide right off the rails and onto the floor. So they're really there just to catch things if something goes bad. And then you can kind of see they do double duty in holding the adjustable sensor pickup on the y-axis. They don't do that on the x-axis, but they do on the y. All right, the second component is the sensor itself. So we've got 3 block sensors like this, or they call them cube sensors, but they're inductive proximity sensors. And then there's 2 of those on the front of on the y-axis direction, and then if you go around back here, there's 1 more on the back of the Y gear assembly. And then on the Z stage. You can see kind of the cylindrical one up on top with the green tip, and then down here on the X gantry there is also the same cylindrical one with the green tip, and you can see the block right next to it. That's the sensor, the block that the sensor senses, and then there's one over here. Both of these types are just inductive pickup sensors, so they emit a alternating magnetic field, and then they have a sensor inside that can detect when that field strength is changing. So as they get close to any form of electrically conductive material, so metal, obviously, they don't have to be magnetic materials, just have to be conductive. These get close, there's eddy currents that start to flow inside the conductive material, which has quite a bit of efficiency loss due to the resistance in that metal. That sensor can pick up that loss in the field, and it essentially trips like a switch. So you take a piece of metal like this, and you can see the light on the side lights up when you get close. It works with aluminum, it works for steel, it works for copper. It's more efficient with steel. But that's how those work. They need some sort of fixed material to sense against, and then they have a built-in facility for you to tell if they're working, and then this wire goes back to the ESS controller, and it's treated like the EMO button. So these are not the software doesn't know that it's getting close to tripping one of these. They're simply there, and the ESS is monitoring them all the time. So if you ever have something go wrong and one of these goes off, Mach 4 is going to stop instantly, just as if you hit the EMO button here. And the downside of that is, unless you're doing the homing operation where this is expected and it's dealt with there properly, if it's any other time than homing, the machine is going to come to a screeching halt, and you'll probably lose motor steps and everything and need to rehome. That's the value of the next item that we need to talk about, which is soft limits. So if you think about this gantry moving across here, if you're not homing, you want it to hit the soft limit first, because that's well behaved. If it gets past soft limits, like you've disabled them or they're not set properly, and this sensor trips off, you're going to basically lock up Mach 4, should probably rehome. If this sensor isn't set right and you bang into the hard stop, you might bend this or whatever. Your motors aren't even going to know you're there, and they're going to keep trying to drive into this hard stop. So that's even worse. You don't want to hit that. Now, if you're jogging back and forth or running the machine at very high speeds, this proximity sensor probably isn't going to stop it fast enough, and it's still going to slam into the hard stop. And that is the value of the soft limits, because the soft limits are boundaries all the way around this machine that are set slightly inside of where these sensors will trip, but the software knows all about where they're at, and every command you give it, whether you're jogging or it's a G-code command or whatever, it's always comparing those soft limits to what command came in from, say, the G-code or the jogging, to make sure it doesn't exceed those boundaries. And so that's why you can jog very rapidly across and just keep holding the jog button down, but once you start getting close, it knows that soft limit's coming up, and it actually intentionally starts to decelerate and everything. So that's the value of always having your soft limits set up properly and in use, is they save you from slamming the machine into itself and damaging things, or having to rehome and reset your all your references on the machine, which, if it happens in the middle of a job, it might mess up, what you're trying to do. You might not be able to reproduce where you were at or something like that. So let's get into how this all works in homing. Okay, I'm going to run the home routine now, and I want you to watch two things that happen here. First, this sensor is going to approach the metal block that's adjustable for for where it needs to stop. It's going to move in and get close to that. When it does, it's going to trip, and this light's going to light up momentarily, saying that it actually detected this block. And then the routine's going to back it off slightly. And what it's doing is it's finding this thing, which is the absolute reference for where the gantry is on the machine, and then it's backing it off slightly because it's going to back, and it's just a little bit, but it's enough to have a little bit of safety margin, because that's going to be, when it backs off to that point, that's going to be the 0 point for the gantry. And again, we don't want to trip the sensor ever again. We want to use the soft limit, so that's why it backs off. So it leaves a little bit of margin. And now the other thing we want margin for is where the sensor trips and this hard stop. Again, as I mentioned, we want that sensor to detect this block, but we don't want this hard stop interfering, because again, this hard stop is only here as a safety measure. So watch it when it closes in. There should always be a little bit of a gap between this hard stop rubber and the metal when it closes in. If you see this thing start to compress when this comes in and detects the metal, that means you're too close, and you basically need to move this out farther away. That was one of the problems I had on my machine, is when I did my squaring of the gantry, when I did those adjustments, I wasn't really thinking about it. And you always have two choices when you're doing the squaring. Is on one side you could screw the sensor in so it goes that way, or on the other side you could screw it in the opposite direction, and either one will help you square the gantry. But in any case, when you're moving one this way, you risk consuming all of this gap that is there, and then you start having a conflict between these. So I'll talk about it again some later, but when you want to do your squaring, always choose the one side to square your gantry that moves it out in this direction, and then you won't ever have this problem like I did. That was a mistake that I made when I was initially setting up my machine. So I'm going to fire this off and we can watch it now. So it's moving in, trips, and then it backs off. And you see, I always have a little gap down here. Even when it was closed in, it picked up the sensor, lit up, and then it backed up slightly. And now the machine is homed in all three directions, and it's basically set where 0 is for the 3 axes. And then it can turn the soft limits on, and using the soft limit settings, it can set the opposite sides for all of those. So when the homing is done, if you have the jogging menu up, you'll see down at the bottom then that the soft limits have been turned on, and if you had your axis limits override button on, it will also turn off. And then it just simply tells you here, this is just an information button that tells you that it's done. But the reason, so what happens is it has to ignore soft limits while it's doing the homing, because it's kind of assumed that, certainly like when you power the machine on, it doesn't really know where it's at. So it's trusting the homing routine to find itself. And that's why you see the homing doesn't run at a real high speed. It needs to run slow enough that the instant it detects that proximity sensor going off, it can stop immediately and not lose any steps. So it's a slow enough speed that the ESS smooth stepper can, command all those motor steps, but then instantly stop and record its position when that sensor trips. So that's why it runs a little slower. And then sometimes if your machine's a little bit messed up, like you slammed into a proximity sensor, or if you're into a proximity sensor and it's actually tripping, sometimes the homing routine won't work either, and you'll have to turn this axis limits override button on and jog away from it, because the jogging routine has to have all the homing sensors in a non-tripped position, because it's actually looking for a transition from not tripped to tripped. And if one's already tripping, like if you slammed it into the axis, or accidentally had your limits overrides turned off and jogged into it, it can't start from that position, so it won't actually move, and you'll have to go turn this axis limits override on, then back off of and then once that's turned on, you can jog off of that and kind of reset your sensor. Then it will allow you to do your homing again, and then it will automatically turn that off when homing is done. And like I said, it will turn soft limits on for you. Now, just to kind of show you how it behaves, if you turn this, I just homed it, so if I have my soft limits on, and you can see I can jog away and jog back in, and it stops nicely, and I can jog away and jog back, and I can do that all day long, and it's not going to hang up or anything. But if I go in here and turn soft limits off, now there's no soft limit calculations. It's going to actually go, so I'll jog back, and now I go hit, and you heard it slam into there, and now you can see the sensor is actually tripped because it didn't have soft limits to stop it. The other thing you see here is in the Mach 4 screen, it's disabled the machine, so I can't jog right now. So I have to re-enable it. Then I can jog away again. And then if I turn my soft limits back on, I can start jogging back and forth again. So that's the reason why you really want to use the soft limits. It doesn't slam itself into anything. It behaves itself. And so if you ever get, if your machine just stops or you hear it clunk like that, that's a good indication that something went wrong. Maybe your soft limits don't have enough margin, or they're set improperly altogether like mine were. So we're going to go through how to figure all that out. Okay, now making our adjustments, the first thing we want to do is adjust our proximity sensors with respect to our hard stops, because that's the first layer of protection here. We always want those proximity sensors to go off before the hard stop, especially on the sensors that are used for homing. So I'm going to go in here and make sure my soft limits are turned off, and now I'm going to jog into, have to back off a little bit, I'm going to jog into that sensor, but I'm going to do it very slowly. And the reason is, if I go into that very fast, as I said, it could overshoot that a little bit, and so it could kind of taint what I'm trying to achieve here. Is what I'm trying to see is have this kind of creep up on this and have it trip, and it'll stop. And then I'm looking and making sure I have a gap here. So I have a gap of, I'm guessing 50 to 100 thousandths of an, it's probably about 50 thousandths of an inch. So that's okay. I just want to make sure that when the proximity sensor trips up here, I have a decent air gap here, because I do not want this hard stop interfering with this proximity sensor. And I'm going to do that everywhere. For these front two, over here on this other side, I have the same thing. You can see I've got a gap on that one. So that was the Y-axis, and then I'm going to re-enable it, back that off a little bit, and then we're going to go try the X on the left side. So I'm going to sneak up on that, and that just stopped. And I can go back here and see, you can see it there. That's the little light that says the sensor's tripped, and the clunk I heard, I know it stopped, and I can see there's a little bit of a air gap there, probably 50 to 100 thousandths again, so that's pretty good. And then I would go and do the same thing on the back, make sure there's a gap to this rubber stop, and then the place where you adjust the Ys are, you would screw this, for example, if there wasn't enough gap down here, I would screw this sensor out, and I would probably do it on both sides just to keep my gantry square, if I've already squared it. If I haven't squared it yet, it doesn't really matter. The place you adjust it on the X stage is this block here. There's one here, and there's one over there close to that sensor. So if you need a little bit more gap, you would simply loosen these two bolts and move it in a little bit, and that would have the sensor tripping earlier, in other words, a little bit earlier before it got to the hard stop. So that's those two. And then this one is hard to tell because you almost have to, there's no hard stop to see. You'd actually have to go inside. But if you just follow AVID's measurements for this, you're probably going to end up okay. The other way you could do it is you could loosen up your sensor, because in this case, the sensor itself is the adjustment, not this. So what you can do is loosen these up, screw it up, and then mechanically bring your axis up very carefully and slowly, because you don't want to damage something inside, until it stops. And then you can lower the sensor until it trips, and then probably add another, say, 50 or 100 thousandths, and that way you'll know the sensor is going to trip before the mechanical hard stop up here. So that's how you adjust all three of your sensors, your proximity sensors, with respect to your mechanical hard stops. So after you've done that, now we got to go adjust our soft limits. Now we don't have to adjust the soft limits on the sensors that are used for homing. So this front one, the left side here on the gantry, left side from looking from front, and the Z one. All of those are automatically set because those are 0. So when it goes up and detects that sensor, it stops and then it backs off some amount, and that becomes 0. So the soft limits 0 value is set right there. So that's done. The only thing we need to set the soft limits for is the one over here on the right side, because it's going to be whatever your travel is to that sensor minus just a little bit. So in my case, it's about 49 inches and some change, and we'll figure out what exactly that is. And then the back one over here, because this stop here uses this proximity sensor at the back of this motor, that is not used for homing. That is only, again, a soft limit, or a safety stop for the back. There is not one of those on that side. And again, you don't want to hit this one. So the soft limit is going to keep us off of this one and off of this one. And the third place is it's going to keep us from slamming the Z stage into the ground. Now, the Z stage is the only one that doesn't have a proximity sensor on both ends. It only has this top one, and it doesn't really need one if your soft limits are working. So they just decided not to put one on there. Okay, let's talk about where our soft limits are set. There's two ways you can do it. If you disable the Mach 4 and go into configure and get your AVID CNC configuration pulled up, you can go over to this custom menu and you see two tabs or two check boxes: enable custom soft limits and custom homing. The homing just allows you to change the behavior of the homing, like if you want to do one axis at a time instead of like X and Y at the same time, or the order or something like that. You don't really need to check that. But if you check this custom soft limits and then hit save, what it's going to do then, I'm just going to cancel, it's going to add up here in the machine setup tab, you'll get a button over here that says custom soft limits. And then when you click that button, it'll pull up a little table of parameters for soft limits. Now, all this is a convenient way to add numbers. It's going to actually plug them into the Mach 4 tables anyway, so I don't really think this is any easier way. So I just simply go into the Mach 4 setup. So I'm going to show you where that is. So you go into configure and control, and right here you have homing and soft limits. And I just homed my machine, and so my basically you got all your axes here that you're using. The soft limits are enabled here because the routine just enabled them. This home speed, this is the speed that it's jogging while it's trying to detect the transition in those proximity sensors. This offset is for doing like some kind of custom offset. You don't really need to do that. They just stay at 0. But the soft and max, soft min and soft max values, these are the ones where you can make adjustments. So what happens is the machine, when it homes, it's going to set that place where the proximity sensor triggered at 0. So that's your min. So the X and Y's become 0. So that picked up the proximity sensor, it backed up a little bit, and now it set that position at 0. And then what it does for the Z-axis is it actually does it backwards. So where that trips is minus 14.5, so that's high, and then the max value is going to be 0. So these two values here are your X and Y's, and what we're going to do is we want to test where that should be. So we're going to turn off our soft limits and go find out where the machine thinks that sensor is. So let's do that right now. Okay, just on my machine, I'm going to test my X-axis max soft limit. So what I'm going to do is jog all the way over to the side first, and in my case, I know the soft limits work because I could hear it decelerate and stuff. So we'll back off a little bit. And now I'm going to go down here in the jogging menu, and I'm going to turn my soft limits off. So what that means is when I jog to the right now, instead of hitting a soft limit, it's going to actually trip the sensor because it's not going to stop at the soft limit. So I'm going to jog. I'm going to slowly sneak up on it here. Try to show you okay, it just tripped and it stopped. And I, again, do it kind of slowly because I don't want it to overshoot that. I want to pick that up and stop it immediately. So we are at where the sensor trips. So we're going to go over here, and you can see it disabled the machine, so that's what I would expect when I hit that limit. So we're going to go into control. Actually I need to check something. So we're going to switch to machine coordinates. You do that up here, and now it says, okay, I homed over 0 on the left side, and you jogged over and hit this, and we stopped here at 49.44. So I want my soft limits to be a little bit less than that. And so this is, maybe 49.3, 100 thousandths. I mean, you don't want to be too much because you're giving up workable space on your machine, but you want to have a little bit of margin there just to make sure that, if something wiggles loose a little bit on that block or something, it's it's not going to be intermittent or anything. So I would probably go back to like 49.34 or something like that, just a little bit, 100,000 inch. So we're going to pull up our control, go to soft limits, and on my X you can see it's 49.299. So I'm easily within my limits there. That's essentially 49.3, and as we said, we're at 49.44 right now. So I've got 140 thousandths of an inch between where my soft limit will trip and my proximity sensor will trip. So this one's very safe. So I would do that also with the Y-axis the same way. Re-enable, and then I would go to the back, get close to the back. I would turn off my proximity sensors turn off my soft limits by disabling soft limits down here. Well, they already were off, so I can just keep going. I'll take my controller and go back here. On this one I can't see the light because it's on the side covered up by the E-chain, but we'll sneak up on it. Oop, there it goes. Now again, you can see I've got it. I don't know if you can see, but there's a little bit of a gap there. So my hard stop is okay because my proximity sensor is kicking in first, which is what we wanted. Again, if I was bumped up against that hard stop, I would just simply adjust this stop in towards the sensor a little bit more, and that would give me more of a gap down here like I want. So we're up against our sensor right now. So if we go look at the machine coordinates, on Y I'm at 49.42. So we'll go pull up the control, homing soft limits, and I'm at 49.42. My soft limits are at 49, essentially 49.3 again. So again, I've got 140 thousandths or so gap between it. So that one's good as well. And I adjusted both of mine to have that same gap. That's not a coincidence. But so again, soft limits kick in first, then the proximity sensors, then if all else fails, hard stops. So now we can do our Z stage. Okay, so Z is a little bit different. It's flipped over backwards the way AVID sets it up, which is fine. So the soft limit min is up at the proximity sensor, and it's called, that's the minus direction. So we want 0 to be down by the spoil board because that's the way people think about it, right? That's the bottom, and then you do your work coordinate off of that's going to raise up. And you know, a positive, it's kind of backwards when you're working in machine coordinates, because when you go up it's positive, but in this case the machine coordinates are opposite of that. And so we don't want to mess with the 0, 0. We want the bottom of the travel to be 0, just like we wanted the front and the left of X and Y to be 0. So we're going to control where the 0 is by changing how far we sit, how tall the stage is, or how far we're allowed to travel from the point where this was. So what we're going to do is go up here, and I'm going to close this. I'm going to re-enable everything so I can Z down. I'm going to get close, and then you can see I'm almost at minus 12, and it was, I think, a 14 inches in the soft limits. So what I'm going to do again is turn off the soft limits, and then slowly go down. In this case, I'm not trying to hit a sensor because, as I said before, we don't have a sensor here. I'm carefully going down until I basically hit my hard stop. Okay, that was it. That's the very bottom. Now, I don't want to go right to the hard stop too much. So this one says it essentially traveled 14.55 inches, almost 14.56, right? So that's the very dead bottom of that, and we don't want to hit that. So 14.558, we're going to go look at, oops, I have to disable again to do the configuration. Go to config or control, soft limits, and 14.5. So between where the bottom is at 558 and the travel here, it's 60 thousandths of an inch extra travel. That's probably okay. So basically, the soft limit's always going to force me to stop 60 thousandths before the actual physical stoppage when it slams into the end there. Again, no proximity sensor to worry about. It's actually worse because without the proximity sensor, it's just going to slam in there, and the motors will actually keep trying to move there if you don't have the soft limits. It's a little bit more of a harsh slam there. So I'm going to leave mine at 14.5 here because that's fine. Okay, so now let's say we want to set up our Z-axis, so we're protecting the spoil board or maybe protecting our laser from slamming into the spoil board, because for some reason, like maybe we just do a bunch of V carving or laser work where we don't actually have to reach the spoil board with the bit or the tip of the laser. We can artificially raise the soft limit to protect ourselves. So let's just pretend like the laser now is at the point where I don't want it to go any lower than that. Or it could be, you might chuck up a large 2-inch bit or something, and the bottom of the bit, you decided this is as low as I want to go. We put it where we want it. Then we go in here and say, okay, that's at machine coordinate 13.1. So we could go to configure. I have to disable first. Go to configure control, homing and soft limits, and then instead of minus 14.5, we could say, okay, 13.1. So we put minus 13.1 in here instead. And now that's going to basically let us travel 13.1 down from the top of the axis, and that's what it's going to call 0. So that'll prevent you from going any further. In my case, the 14.5 actually doesn't get me all the way to the spoil board for really short bits. And that was an oversight on my part. I mounted the spindle itself a little bit too high on the Z stage, and so I can't actually get down there. The 14.5 gets me to right there. So when I have really short bits, or I want to laser on something very thin, I actually have to put some material under it. So one of these days I'm going to get in there and lower my spindle and laser mount, but that's a bit of work to do tramming wise, and so I don't really feel like doing that until I have some spare time. One other thing I wanted to mention is a lot of people miss it because the print down here is so small, but whenever your G code is running along fine, or maybe even just doesn't start to run, just sits there, I always take a look down here in the history window. It's really small, so it's easy to overlook it, but if it's most of the time what it is you've put the workpiece somewhere on the table, or the workpiece is just too big no matter what, so that the it's outside the boundaries of the soft limits, and it'll say something like commanded outside of the soft limits or something like that down here. But like I said, a lot of people don't notice it, but that's the sign when the G code is asked Mach 4 to go outside the soft limits, and it'll just stop. It doesn't do that. Like if I travel right now and I just Z'd into I jogged into the Y-axis limit, you say it doesn't change there. It doesn't do that when it's jogging, it just simply stops. But when you do it from G code, then it tells you. But again, it's very small print. I changed my window so it prints out in red, so I notice it a little bit better, but it's still very small, especially on a laptop. Okay, so in summary, we want to adjust our sensors for our proximity, or our stops for our proximity sensors, so that they trip before the hard stops, and then we want to then adjust our soft limits so they trip before the proximity sensors. And if you do that, you're going to have a well-oiled machine. It's not going to go slamming into the ends of its axis travels, and it's going to warn you ahead of time when you try to move somewhere where it's outside of those boundaries. So it works very well. And the only other thing I want to say is just a reminder of when you go to trim the squareness of your whole gantry with respect to your machine, you're moving your left and your right Y stop gantry sensors. You're going to be turning this in or out and turning this in or out, and anytime you want to twist that axis a little bit to get it square, you have a choice of turning one side in or one side back. And what you don't want to do is choose the one where this is going back, because you're moving that sensor towards the hard stop down here, and you'll probably adjust it to a point, or there's a good chance you will, where you'll start hitting down here before the proximity sensor kicks in when you home. So like I said, there's always two choices and there's one right one, and that is to pick the one that gets you more square by moving the sensor or the stop in towards the sensor, and that will always keep you out of trouble from a conflict between your proximity sensor and your hard stop. Okay, hopefully that was helpful for folks. If you have any questions at all, or I didn't explain something clearly, please put a message down in the comments section. I always look at those and I always answer them. Thank you.